In the following expression, what type is inferred for question mark? Well, since we're applying f to a number, then the argument x must have type number for our things to work out. We're also returning x, so number works for both of these question marks as well. So number is the answer. Piece of cake. How about in this expression? Similar reasoning to last time, but this time instead of passing a number, we're passing a function from numbers to numbers. So num arrow num goes in place of each question mark. This is num arrow num, this is num arrow num, arrow num arrow num. How about this one? Let's assume that we have booleans and conditionals, and let's assume that we put some expression here that has type boolean. Now our problem is that we're applying f to a number and also to a num arrow num function. And so there's no type that we can put in place of this question mark here that's going to work out. Even though if we run this expression, we will get a number out. We'll either get 10 or 8, depending on what expression we have, ... as long as that expression also would have a type. So we have an example of a program that runs that doesn't raise an error, that in fact looks useful. F could be the identity function, and we're using the identity function on 2 different types, but our type system doesn't currently support it. So we'd like to extend the language somehow so that we can write these things. And the idea is that we're going to put a type variable here, which I'll use with quote A, with a quote mark on the front. So, and I'll read quote A as alpha. So I'm saying that x has type alpha, where alpha is supplied by an enclosing lambda. And this lambda is in capital letters because whereas this lambda takes an expression, takes a value to substitute into an expression, this lambda takes a type to substitute into an expression. And when we apply a big lambda, we use an @ sign instead of just an implicit application. So this is a type application that's applying f to num, the type num. So num goes in for alpha here, and we get a function that takes a number and returns a number. So that's fine. And here we use f again, but this time with num arrow num, which means it takes a function from numbers to numbers and gives us back a function from numbers to numbers that we can apply to 8, and so on. So f isn't really a function anymore, it's a polymorphic function, or a type abstraction over a function. Right? And in general, we're going to use big lambda to parameterize an expression over a type, and we will match big lambdas with @ signs when we want to apply polymorphism. So for this expression to make sense, then we need to give a type to all the sub-expressions. Clearly this should have type num arrow num, but how do we get there? What is the type of this part in the square brackets? What goes in place of the question mark here? What is the type of just this expression by itself? Well, it's something like alpha arrow alpha, right? This part inside should be alpha arrow alpha, but alpha arrow alpha is the type of this. For the type of the overall thing, we need to say, first you have to give me an alpha before I can give you a function back. Or you can even imagine 2 big lambdas wrapped around that function, which again is something like alpha arrow alpha for this, the type of this expression, but we need to say that you have to give me 2 types, an alpha and a beta, before you get that back. So to write those types, we need a new way to write things in the type, and we're going to write it this way, using for all the name of a type variable and then a type. So this means give me an alpha and then I'll give you back an alpha arrow alpha, except that I'll substitute in whatever you give me when you apply it at runtime, right? But the type overall of that previous expression is here. This expression with 2 big lambdas has a type, 2 for alls. First give me an alpha, then give me a beta, then I'll give you a function from alphas to alphas. In this mathy notation, we're going to use a for all sign as an upside down A. Also, I'll abbreviate quote sim and type as A and tau as before. When we write concrete syntax, we will have to spell it out, though, or it's easiest to spell it out. So the concrete syntax is for all quote sim. And then we also have quote sim as a type, because that's when you're referring inside of a type, when you're inside here, referring to a type that's going to be passed in.